I had a confusion regarding the Cartan subalgebra. Will it be possible just to explain the definition? I mean, it wasn't
Right.
clear for me with the...
Yeah, so that's, yeah, good. So let's look at the Cartan subalgebra. Okay, so this is an algebra of a Lie algebra. So suppose you have a Lie algebra say G tilde, which consists of say x1, x2 dot dot dot, say xn. So these are the generators, okay? So the subset of G tilde, that consists of mutually commuting generators is called the Cartan subalgebra. Okay, so of G tilde, there is some subset, say C tilde, and C tilde consists, say, of H1, say H1, H2, dot, dot, say HP, such that all the H's in this set commute with each other. So this is the maximal set. Maybe I should insert the word maximal, maybe the maximal subset. Okay, the maximal, then, then C tilde is the Cartan subalgebra. Okay? This is a general definition. Is the definition clear, Nahi?
Yes, sir.
Okay. So for SON, where n is, say, 2k, we found that there were k commuting generators, right? And for SO 2k plus 1, this was the same. So the dimension, or the dimension of the Cartan subalgebra, or the number of elements in the Cartan subalgebra, is called the rank of the Lie algebra and the corresponding Lie group.
So what is the dimension of CSA?
The number of generators in the Cartan subalgebra.
Oh, okay.
Okay. So yeah, and that's called the rank. Okay. So here for these guys, for SO2k and SO2k plus 1, it's k. And how did we manage to figure that out? Because for SO2k, we are in some 2k dimensional space, right? So there are 2k dimensional orthogonal, so this is x1, axes, x2, x3, dot 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 x2k. And we find that if we do a rotation in the, say, in the x1 and x2 axis, and a rotation in x3 and x4 axis, then they should all commute, right? So we can, if you have 2k dimension in the space that SO2k is acting on, we have 2k minus 1, 2k. We have k independent rotation, right? These rotations should all commute. Any other rotation will not commute with all of them. So from there, we figure out that for SO2k, the Cartan subalgebra has k generators in it, and therefore the rank of SO2k is k. And if I consider SO2k plus 1, if I add a new direction to the space, because this new direction doesn't have a partner to pair up with, we don't really get a new rotation that's going to commute with this bunch, right? So that doesn't change the rank of the group in the Lie algebra. Okay, so any more questions?
Sir, I have one. On the real number line, we couldn't make real number times multiplication including 0 because 0 has no inverse, right?
Yes.
But we could make a group excluding 0. So is there any sort of group, like we can exclude the group elements whose determinant is 0 with some conditions?
You probably can. I haven't thought about it, but that'll probably be like isomorphic to one of the matrix groups. That's a very good question. I haven't thought about it. Yeah.
Okay, sir. Thank you.
Yeah.